So a line of best fit is best suited for a graph whose points are kind of like this, where if we were to connect all the dots, you would not have a linear relation. In fact, the way these lines connect wouldn't show much of a relationship at all. Now, when you look at the general trend of this graph, we can see that it's not true, that it generally goes up. So what the line of best fit does is it allows us to draw a straight line through the data that generally represents how this graph is going without connecting every single dot and ultimately forming a strange, rather unpredictable graph. So if we're going to ultimately do the line of best fit here, what we're going to do is we're going to start from one of the earlier points. And I always say actually start from the earliest point. So this point here, the point that's most on the left. You start from that point, and then you see which line, and it should be a straight line, hits the most amount of points as possible. So I can see if I go here, I only get 2 points. If I go here, I only get, essentially 2 points as well. Or here, 2 points. So none of these seem to be as good as if I go through here, where I actually hit all 3 points here. Now, the second part says to take the slope ignoring all the outliers. So once I made a line from the first point that hits as many points as possible, then all these here, I'm going to kind of highlight them here. These are the outliers. And so they're not going to be included in our data set. And what an outlier is just an anomaly, meaning it's kind of like a mistake, or probably something happened in the experiment that caused this data to be miscalculated or misconstrued. So we're going to take the slope as we normally would, whereby I can pick, I'll do this in orange here. I'll pick the first point and last point over here. And then we're going to follow the slope formula. So below over here, you can see that I did the y2 minus y1 over x2 minus x1. Just to recap, that the first set of points, or the point that is most on the left, is going to be your x1 and y1, and then the point that is the last on the right of the graph is going to be your x2 and y2. And so I did 7 minus 1 over 2 minus 3, and they give me a slope of 6 over 5, which, since the value is positive, makes a lot of sense since this graph goes up. Now, in terms of how I got these numbers, again, just to recap, I used what we call interpolation. So from the point, I made a straight line down to see which x value it hit, and then I made the line across until I hit the y-axis of the chart, and then that was my 1. And then I did the same thing with the second point here, where from the point, I made a straight line all the way down until I hit the x2 value, or the x value of 2. And then I made the line across until I hit the y-axis, which was 7. And then this gave me the slope. But again, all of that wouldn't have been possible if I didn't make that line of best fit, which is I started from the first point and then made a line that hit as many points as possible and just simply ignored all the outliers. Now, for this graph, I'm going to do the same thing. I know that generally the trend is that this graph goes diagonally downwards. Now, if I were to connect the dots, I would see that I get kind of a weird trend, right? Something that's not a straight line and is generally a little bit unpredictable. So we're going to use a line of best fit to show a straight line that generally represents this data. Now, like we did before, line of best fit is we're going to take as the first part here, we're going to start at the first point, and using a ruler, we're going to make a line that hits as many points as possible. So from there, we can test a couple. If we were to make it go through here, well, that wouldn't really go anywhere. It hit 1 point. If I went through here, again, that would only hit 1 point. If I went straight through here, it would only hit another point. But if I go like this, then once again, I end up hitting more points than I would with any of the other lines. So this is my line of best fit, the line that hits the most points from the first point. These over here, these are called our outliers, and we're going to ignore those. So again, what I did was, using the first and last points, I used the slope formula, y2 minus y1 over x2 minus x1, and I got a negative slope. And since the line kind of goes downwards or trends downwards, then the negative slope is only fitting. Okay, now if I end up getting a positive slope, then I know that I must have done something wrong. So again, to recap, from the first point, we drew a line with a ruler that hit the most points out of the whole data set, and anything else was just an outlier, anything that was missing. So this, and this. And then once we did that, we took the slope of the 2 points of that line using the slope formula, and we got a slope that matched the trend of the graph.